put it in the same PDF. Just put the email and just put the first part and the second part in the same PDF, and then what you need to do is, so the part one, part one is the diagram, and it's that business canvas diagram of, I'm trying to remember how exactly it works, it was something like this. So you'll need to use one of the Microsoft Office products to build a diagram. Whichever one you can use. There are many different choices, including Visio would work for drawing a diagram. Anything that, actually you can just do it in Word, right? You can just make a table in Word and put it using merge cells, right? To make a table that looks like that. Then just put in a header for part two, and that's going to be text and header of an email, right? So it's a practice at composing an email. So just one document, right? So single PDF, first part of the PDF, and just put a subheader, part one, the diagram, and actually I do need, oh no, I don't need your name because I'm downloading it. Part one is the diagram, and part two is the email and the title of the email. Does that help? Yeah. So you could do that all in Word if you wanted. You could make the diagram in Visio and then import it into Word, whichever way you want, and then just finally export it as a single PDF and upload it. The reason why I asked for PDFs is PDFs are less. You can still edit PDFs, but it's a lot more difficult to do it, right? So they're less malleable to me messing them up. They also, reading PDFs is it's easier to read a PDF than it is to read it through Word, because Word throws a whole bunch of extra stuff on there, and a PDF is oriented towards just reading. So generally, I try to insist that all sort of like written documents are exported to PDF and then uploaded. Any other questions about the designing data projects? No? Okay. Good stuff. All right. So
only single file is enough, sir?
Yeah, single file with two parts.
Okay, got it.
And sure. So let's just set the HTML.
Multiple
export the business model canvas as a PDF and split it to okay. Include the canvas as the first part of a PDF. The second part will be the contents of the email. Submit the single PDF to your instructors. Is that good?
Yes.
Okay, and I won't set notify, I'll just save it. There we go. All right. So I've put onto Teams for everyone to download the hurricane data that we generated today at lunch, and we're going to work with that. Save it off. You create a folder if you want. I've got a folder created called hurricanes, right? And I've saved off the data as hurricane.csv, and that's the data we're going to work with. So today's class will be introduction to geographic and geometry data. Right? So we will be covering the bare bones basics of a point, a line, and a polygon. And this is the main thing we'll work with today. And we'll show how to use them to create animations. All right, so I'm just going to start up Tableau, and we'll do what we always do by opening up the data set and I'm going to connect to a text file, and I'm just going to go into the examples. This is a long time ago. Courses, 24. I'm going to grab the new hurricane data, open it up, and we're just going to take a look at what we have for our files. So the first thing I'm going to do is I'm just going to rename this as hurricanes, or I could call it storms, anything. So you can call it storms, for example.
So just a second, let us download and.
Okay. So I'm going to stop and cancel. No, I'm not going to set the workbook. I'll start from the beginning again. So we're going to have Tableau. I've got a folder where I've downloaded the data to. Yeah. And so, right, remember I've got the data here. I've got the data here, so I've just downloaded the data and I put it into the folder somewhere. So it's gone to my downloads, for example. Assuming I've synced the file somewhere, I'm going to open it in Tableau. So I'm going to say open a text file. There it is. There's the data I saved. Hurricane date.2. Technically, I just moved it over from the folder I was working with in data process in Python for data. So I'm going to open it. So it's a text file. It's a CSV file. It's read 21 columns. I'm going to just scroll through the columns to make sure I got everything. The identifier, the basin, the storm, the number of tracks, the observation date, and it picked up latitude and longitude correctly. And it's interpreting the radius as strings. Right? So it looks like it's picked up all the data. I'm going to have to tell it to make these strings into, I'm going to have to tell it to make these strings into numbers, and I happen to know that these are all integers, same with the maximum wind speed and maximum pressure. I'll check to make sure that the names came across with the units of measurement. I'm just going to expand over, look, it's got the units of measurement in there. So it's picked up, looks like it's picked up the headers really nicely. So the main thing I can do is I can just say, rename this, and we'll just call it hurricanes. Why not? There we go. And we'll just go through storm number. It's a whole number, that's good. So what I'm doing here is I'm doing the usual work of checking data types. I'm happy with that as a string. I'm happy with that as a string. I'm happy with the basic name as a string. The storm number is being listed as a whole number. That's great. Storm season, that's a whole number. Storm name is fine. Storm tracks, is that going to be a whole number? Yes, it is. The observation date is a date and time. Perfect. All right. This is looking really promising. The classification of the track and the storm at the time of observation is great. The latitude picked up. Notice the globe icon. That means it's picking that up and interpreting that as a geographic element. And longitude is being picked up as a geographic element. And finally, minimum and maximum wind. Let's just make sure those are whole numbers. Yes, those are whole numbers. Now, the tricky bit is because the first few thousand records have no radius on them. I'm gonna tell them. I'm gonna override it as a whole number and say, oh, that's a whole number too, and that's a whole number, and that's a whole number. There we go. So let's take a look at how things. Before I actually create an extract, I'm going to take a look at how things look on a sheet to see what comes across as a measure and what comes across as what came across as a dimension. So a few of these things are coming across as dimensions when they should be measures. So I'm going to change the radius into a convert to a continuous and convert it to a measure, and I'm going to do that for each radius. And I'll check. I can check the data type. It's still saying a whole number, but I want it to be continuous, and then I want it to interpolate positions. I'm going to convert it to radius. Same thing here. I'm going to convert that to continuous, and I'm going to convert it. And I'm just going to check the data type. Still a whole number. Good. And I'm going to convert it to a measure. Storm year is fine as a continuous. That's fine as a continuous dimension. Storm number is a dimension. That's great. Southwest radius. Let's convert to a continuous, and we'll convert to a measure. And the rest is fine, right? The storm types, storm codes. So we can. For example, I can do track and track code and track type, and that looks good. Nulls match to nulls. We've got all those looking correct. I can do a quick visual inspection of the storm code and type.
So why was it continuous, sir? Like.
Oh, why?
Yeah.
Okay, so the reason why you make these continuous by default is so that when you drop them in as a column or row, it forms an axis as opposed to individual categories, right? If something's discrete, then when you drop it into, say, columns, what it'll do is it'll create distinct columns, right? Whereas if it's continuous and you drop it into columns, it creates an axis, right? Where there's infinite interpolation, right? You can create lines to any degree. So that looks good. I'm going to go back to the data source, and I'm going to say, yeah, this is great. Let's create an extract. I like the way all that works. Go back to sheet 1, and it's going to ask me to save this. And I'm going to save it as a hurricane hyperfile. So I'm going to say hurricanes, like that, and it's a .hyperfile. I'm just going to say save. There we go. And finally, I'm going to just save this whole workbook. And I'm just going to save the workbook as hurricanes. And the first sheet I'll do, I'm going to rename this, and I'm going to call it check storm decoding. Right? And it's going to be really simple. I'm just going to take the storm type, and I'm going to take the storm code for it, right? And finally, I can just put in the counts, for example, in here. All right. So there are a couple codes in here that are, if we look at this, that we're not translating correctly. So I'm going to check the table here, our translation table. Oh, and look at this. They're not in there, right? So that's a to-do. We don't have, we'll have to we'll have to check a secondary source for those for now. So I'm going to sort these, and I can edit the sort to put the nulls at the top.
So what did
Oh.
you do? Sort ascending?
Yeah, so, and then I can clear, oh, I should be able to clear the sort. Oh, that's not, there, I just cleared the sort. So if, there are a couple ways to do that. One way is I can click on the actual element and say sort, and then I can sort ascending or descending. So let's try sorting ascending to see if that works. Okay. And the problem is that I need to clear this sort because it's fixed on. I can't resort. The. Actually, if I just move this over, there we go. That's all I wanted to do. So we've got 4 codes here that we're going to need to address later on. We've got 4 codes here that we're going to need to address in our code in Python later on, and we wouldn't have found these if we hadn't done this in Tableau really quickly. So that's not bad. It's not a lot of storms. The next one we can do is check the. We can check the track decoding. And we'll do the exact same thing again. We'll put the actual code of the track and the decoded type. And this time we'll sort this. Yes. Okay, good. And
So what did you do? Ascending?
yes, I did ascending. And alphabetical.
Alphabetic?
There we go. You know, why is, here's the sort. I can do sort and ascending, for example. And enter. Yeah, that's ascending, yeah. And finally, we just want to know how many records have nulls. You just drag it in there. So most of the records have no record of the track type, which we know is correct. And then what we see is that our mapping is correct, right? This was the input that we had in our Python code, and we had a decode to write these out. So that's good. So it means we wrote that part of the decode correctly. So that's just like the tiny bit of code that we need to do. Now, the really interesting stuff is the geographic stuff. And what I'm going to do is I'm going to reproduce something that I worked on Friday for us to do. So I'm going to open up my old workbook. This is going to be what we're going to reproduce with our new data. And I'm just going to go back and forth. So I've got paths by magnitude, storm paths by magnitude. So we're going to reproduce this. So let's call this paths and I think that was wind speed that I used. And magnitude, because I used pressure and wind, so it is magnitude. So I'll say paths and intensity. So because we were careful and diligent in Python about making sure that these got converted to proper decimals, Tableau picked those up automatically. So what we can do is we can drag longitude, and remember what longitude is. We've got our globe. So latitude are the rungs of the ladder. And then longitude is how long it takes you to walk around the planet, right? So if we're plotting this out, right, longitudes are our columns. They're going to be our x-axis, and latitude is going to be our rows, our y-axis. So we'll draw latitude into here, and longitude into here, and you can see it picked it up as a average automatically, and what we can do is disaggregate the marks. So I'm going into analysis and just turning off mark aggregation, default mark aggregation. And look at that, we got gazillions of points. And let's just zoom out to take a look at it. Or I can pan, for example, I can use the panning tool. Pan this over a little bit. There we go. So this is a start. Like we've got the data points up there already, and like every single storm point from during the whole data set. So that's a good data quality check as well. One of the other things we could do is we could have just straight up gone and said we could just check latitude. And what I'm going to do for this is turn it into a table. So I'm going to drop latitude into my rows. I'm going to, in my analysis, I'm going to get rid of the aggregate marks, and I'm going to make it discrete. I'll make it a dimension, and I'll make it discrete. And I'll turn aggregate marks back on again. Aggregate marks, there we go. And I'm just going to put a count in. There we go. So we've got our latitudes going from 0.4, which is right next to the equator, all the way up to almost 90, right? So almost 83, which is very close to the North Pole. The important part is no nulls there, so we know that that translated properly. And I'm going to actually do the same thing here. I'm going to check longitude, just to make sure our data is good. And same thing, longitude as rows. I'm going to treat it as discrete, and I'm going to treat it as a dimension. Discrete dimension, please. And oh, we've got some null records there. That's a bad sign. And how many do we have? One record where the longitude did not translate over. And one of the tricks you can do is there's this little magic icon over here. It's called View Data. So you can actually view the data that contributes to that. And I can view the full data set. And I can say, show all the fields.
So can you go back how to view that?
Yeah.
Sorry.
So if you want to view the underlying data of a specific point, you can hover over it.
Okay.
Click on it. As soon as you click on it, as clicking is also called
Okay,
selecting.
view data.
Yeah, and then view data, view data. That's right. And then we can say view the full data, and I can say show all the fields.
All the fields, okay.
Right, and now I can look up which. Oh, look, I know which storm this is, and it has no longitude, but it's got a latitude. So I can go. What I could do is I could go and look that up in the original data source. It's the eighth storm from 1969. So, for example, in the Atlantic. So I could actually look that up directly in our original data set. So we can go to the original data set that we were working with, data 1. And we'll open with Notepad. And let's just see what happened with that. See if I can edit and find and edit find AL 08 1969. So there we go. Hurricane Debbie. And one of these records did not translate over the longitude properly. So let's, I just need one more bit of information from Tableau for that, which is the observation date. And it was the 6 a.m. on August 27th. So let's take a look, see if we can find the 6 a.m. on August 27th. August 25th, 26th. There it is. Oh, there's something we didn't account for. The fact that they could put in a negative sign into that. That's so the only record where they put in a negative sign into the westing, and isn't that interesting? So that's just a little bit of another little piece of code that we're gonna have to keep track of. But the next part is that doesn't materially impact our data set, right? So we've got the reason why I put the record counts on this data check in Tableau is to try to figure out if it materially affects anything. If there was 1,000 records in here, I'd be like, oh, this is a problem. Like we really messed things up. But because it's just one record, I'm not particularly worried about that. So we've got these dots.
Question, sir.
Yeah.
In the Python class, you assume that we assume that negative west is always like negative, right?
But they put the negative sign in there ahead of us.
Yes.
So that's one. Sometimes it's called a corner case or an outlier that we just didn't know, right? It's not until you look at the data that you can actually determine if your assumptions are off, right? That was an assumption we made, and the data said, oh, there's one record that broke that assumption. So what we can do is we can go into Python, put it in a little code to catch that one case, and that's it. What you don't want to do is put in code that says, if it's specifically storm AL 08 1969. Instead, what you want to do is say, if the record is west, actually what you would do to handle that is simply strip out all leading negative signs, so that you know that if you put the west in, it becomes a negative, and if you put the south in, it becomes a negative. So we just simply strip out the. So that's the strategy I would do in Python. And in fact, I'll update the Python code after class and then upload it. Did I already close Notepad? Yeah. So all I would do for that case is I would simply remove leading negatives, and the reason is because we want the sign to be set by north, south, and east versus west, and that's it. Right? So that's what we do in the Python to deal with that situation. Okay, so back to we've already got something pretty decent. Like we've got an idea of what's going on here, and we can do I think I can make this a density. There we go. It's kind of a cloud density of where this is a density of where the storm observations occurred. But the plan is to make this like an actual path diagram with connected paths, and also to decrease the amount of data we're showing at once. So the first thing I did is I was looking at this and I'm like, oh, this is way too much data all at once. So what can I filter on here? And what I can do is I can filter by the year of the season start. And the reason why I use the season year for the filter is because there have been a couple of hurricane seasons where hurricanes have lasted into December. And so that season is still considered from the year before, but it's just that it had a really hot fall, when fall was really warm, so you had hurricanes lasting until December. So I'm gonna filter on the season year. And I'm just gonna start with a basic continuous filter for now, and I'm gonna update that to discrete. It's gonna say make it a discrete filter, and I'll just use one value for now. Say okay. So we've just got one set of one season of storms, and I'm going to show the filter, and I'm gonna update it to make it really nice and easy to use. So I'm gonna say, oh, you know what? I'll make it a slider. I think I made it a slider. And let this one be just double check. Yeah, I did. I just made it a slider. And then you see we've got a whole bunch of extra buttons in here for things we can do. So I went in and I just I customized it. And the first thing is I want to get rid of the show all values button. The show all values button, what it does is it'll turn off the filter and show and go back and show everything. So I'm gonna remove that. And so I'm gonna customize, remove the show all values. Now if I remove the readout, let's just see what happens here. Customize, remove the readout, you can see you can't tell what year is there. So I'm going to customize and show the readout. And then I'm going to customize, now the slider and the buttons. This is the slider, these are the buttons. I'm going to keep those because that's nice for searching through. But I'm going to get rid of the search button so you can see the little search arrow is gone. And I'm going to get rid of the show include, exclude. Don't need that. And I'm going to get rid of the show control types. There. Now this is a very, you can see now this is a very simplified interface to work with. And then what I can do is I can update this and I can say for season, and then I'm just going to insert the season. Apply.
So after the slider, you customized, and what did you do?
I got rid of, so what I did is I got rid of all the extra diddly bobs and buttons. So
Okay.
I got rid of show the search button, which was the little magnifying glass. I got rid of show include. I got rid of the show all values because I want to make sure that the user can only show 1 year at a time, right? I don't want them accidentally like spazzing everything on there. And then the show the more fewer buttons, I got rid of those, and those are used for like expanding and decreasing detail, and I don't need to do that. And I don't know why that's grayed out and selected. That should be ungrayed because, but either way, it's disabled by default right now. So I basically just cleaned it up to so that when they use this, it's just a single line. Now, so that's showing the year. Okay, so again, just to recap, the reason why this works so well is actually because it's not just that these were numbers, it's that we actually included in here calling them latitude and longitude. If they'd been named something else, if they had been named east-west, north-south, or my row and my column, or X and Y, Tableau would not have picked that up as a geographic element. It would have said, I don't know what this is. Another thing that Tableau will do is if you have a field that's named city or country or province, it will automatically assign that as a geographic. So it just does that automatically. Now you can override that role, and I'll do this to actually break our block. So I can go in, and you can see geographic role, and it's automatically assigned it. And what I can do is I can break all of this by saying, hey, no, this isn't a geographic element. And I can break this and I can say, hey, you know what? This is not a geographic element. So now it's just a plot on a graph. Okay? And I can just keep scrolling through these. One of the important parts about assigning a geographic role to a field is that when you assign a geographic role to a field, it connects the data, right, to what's displayed behind the data, to the map that's displayed behind the data. On top of that, specific things like provinces will, if you have a dimension named province, for example, and you say geographic role is province, what it will do is it will create the polygon outline of the province, right? So if I had a data set that was like insurance defaults or insurance payables by province, and I had the province there, I could assign that the role of Canadian province, and it would actually draw out the province, and I would be able to assign a number to that province, so color the province by a number.
How did you create,
Yeah,
change that from geographic element to?
Well, how about we put it back to how about we make it a geographic latitude and longitude again?
Yeah.
So you just click on it, and similar to having changed data type, it's a decimal, that's correct. You can also say change the geographic role. And you have a large number of geographic roles. Some of these represent polygons, that is areas, and some of these represent points. So cities represent points. Area codes are polygons. Air points will be points. Country and counties will be polygons. Latitude and longitude will be specific points. States, provinces, zip codes, and postal codes will be polygons that get filled in. So I'm going to go in latitude. You know what? Probably should be latitude. Now, if I flip these around, it'll look. If I flip these around, let's do something wonky and flip them around. We'll say latitude has the role of longitude, and longitude has the role of latitude. And come on. Oh, and I'm going to set. I have to change this back to a map. Oh, and I didn't like that. Maybe if I take both of these off and put them back on again. So if I put, interesting. So, really, if I put it up here. Yes, perfect, that's what I wanted. See, so I reversed their roles. I said the name latitude corresponds to longitude, and the name longitude corresponds to latitude. And now all our data is down in the. You can see all our data is down in the south. It's down in Antarctica, and the reason is because the numbers are totally opposite, right? So it's taking all the data that's supposed to be here and flipping it by 90 degrees, putting it on the bottom. So let's fix up those roles and make them work properly. Take those away. So I'm going to say latitude has a geographic role of being an actual latitude. Latitude has a geographic role of being an actual latitude. Longitude is going to take the geographic role of being a true longitude. And then remember, longitudes said how long you are around the world, so those are going to be your columns. And the other way to think about it is, like, longitudes form these nice columns, right, like this. Latitudes form nice rows. So we put the latitude in here, and we get everything back, just the way it was before. So I could do things like, let's see what would happen if I said that this was a country. Now, if I drop basin on here, oh, that didn't do anything. Let's see, I'm saying basin as country, it's probably gonna say, yeah, it didn't identify any of the countries, right? So there is no country called Atlantic, and there is no country called Pacific, so that doesn't work. So you can assign a geographic role to any field. The caveat is, if none of the values in that field correspond to an actual, say, country, then it's not going to plot any data, right? So by assigning the geographic role of country to the basin name, to have this work properly, the values inside of this field need to be actual countries, like they need to be the names of countries. Now behind the scenes, Tableau actually maintains a little database that translates names of countries, names of counties, area codes, things like that, into, and they're gonna say it doesn't have a geographic role, because it doesn't. So behind the scenes, Tableau has its own geocoding. So, and geocoding is the process of mapping names to points, lines, or polygons on a map. So it's just when you geocode something, it's just a table. Actually, and I'll just say that is a table. Geocoding is a table that relates names to either points, so like UTM points, or lines, the space between things, or polygons. And behind the scenes in that table, it's going to have something like a name, and then it's going to have what's called a geometry field. And a geometry can be a single point, x, y. It can be a line, so it can be x, y, and then another x1, y1, and so on. Or it can be where it's that the formatting in there is specific to it's like shape files and things like that. The important part is you would have name, and then you'd have like a point name, and then a way of defining a point. So maybe, like I might be able to find a data set that contains the outlines of the different basins, the North Atlantic, South Atlantic, North Central, East, and South Pacific basins. And you know, if I could find a data set that had that, then what I could do is I could say, go into mapping, geocoding, and I could import a custom geocoding. And it has to be formatted the way Tableau likes. It has to be like a specific CSV file. But basically, I'd be able to say import a storm basin geocoding that has the polygon that outlines, you know, the area of the Atlantic that storms form. And what that would allow me to do is assign basin name the role of basin, and so what would happen is I could, like, for example, color the basin based off of the number of storms in the year. I don't have, I might actually be able to find it, but I don't have one right now. But that's one of the ways that you can do that. So for now, those are the for now we're just gonna use the latitude and longitude. The other place that geocoding can come in handy, where you do have like lots of free available resources, is, for example, the provinces of Alberta electoral divisions, right? Where each, you know, how big each returning division, and not just like the voting district, but the actual like returning division where you go and cast your vote. You can get geographic map files for that, and you could use that as a custom geocoding. So if you were doing any data analytics for a political party, you'd be able to geocode like election returns on a map. And you could color individual returning offices by maybe the percentage of voters that voted, things like that, or how many. Maybe you're doing, maybe you're working for a political party, and you want to know by returning office how many voters voted for you, and you'd be able to do that, and you'd be able to by importing the custom geocoding and then linking it to the actual returns data. So it's actually quite a powerful part of Tableau. And hopefully you guys get to use it, or have a neat project that works that way. Yeah. But for now, we've got our path and intensity, and what we want to do is we want to start linking these as a single path. You can see that these are individual points, but there's no sense that they belong together as a single path. So what we're going to do is we're going to change this into a line chart, and that's terrible, right? It's basically just, you can see what it's doing. It's going from left, it's going from left to right, and it's just like linking every point it has. So first thing we need to tell it is, hey, I want a line per storm, and that's where the storm identifier comes in handy. I can say, I want my detail to be storm identifier. That's not bad, but you can see for some storms, it's still doing the left to right, and that storm actually went like this, but it's picking up all the points, right? So I need to tell it the order, like what order do I want that to do? And I want the order to follow time. So I'm going to say.
But that's observed.
Yeah.
Observed.
And I'm going to set it to the exact date. And there are our storm tracks, right? So each track, right, goes along here. We've got each track laid out, and what we can do is we can say, we can edit the. I wonder what happens when I. Oh, there we go. So if I just highlight over it, I get a little bit of detail about that. It's just telling me which storm it is. It'd be nice to have the storm name. So let's put the storm name in there. If the storm name is available, we'll get it. So we'll say storm name, and we'll make it part of the tooltip. So now we can highlight over and, Storm Allen. That's pretty good. Now, the next thing that I did is I set the size to correspond to how powerful the wind is. So we've got our maximum knots, and I want bigger, like larger winds to correspond to a wider line. So I'm going to take this, I'm going to drag maximum wind in knots over to size, and there we go. That's a start. And so we can see, and let's scroll a year forward, scroll a year back, and so we get different tracks on different years. And the next thing we can do is we can edit the sizes. So again, another data quality check, because we're working with the wind speeds. Let's check the data quality in the winds. We should have a bunch of nulls. Actually, probably not for wind. For pressure, we'll have wind. Name this, and we'll go check wind, and we'll just drop the wind in. And part of the reason I'm doing this is to get a sense of. So there we go. It goes from 10 all the way up to 185. So if I do a scale from 10 to 200, that would be great, right? So one of the things I could do is I can play around with this, and I'll show that, play around with the starting point. So let's just take a measure of how much there is. So we can see that the bulk of our winds, the bulk of our storm winds, happen in the 30 knot range. So I probably don't want to set the minimum lower than 30 knots, right? Because then it's gonna say like all of these get washed out together, right? So I might actually be safe setting the lower bound to 10 knots, and then the upper bound to catch everything and to be a round number, set it to 200 knots. If I want to be really clever, I could set it from 20 to 200 knots. And let's over to check wind speeds, path, and intensity. So edit the sizes. And what I can do is I can, one of the first things I can do is, and usually it says include 0. Start value is going to be 200, end value is, the reason why I'm doing this is because right now, actually let's cancel this. Right now, every time I change the year, the scale on the wins change. You see the scale changes year to year, which is going to make it hard to compare as we go from year to year. So the reason why I'm setting the scale, I'm going to set it as 20 knots to 200 knots. And the reason why I'm setting that is so it stays fixed from year to year. And then I'm going to say, I want the sizes to vary from 0 every time. And that just assures me that it's going to stay fixed. And then what I can do is I can set the range over which these things vary. So I can edit the sizes. And so I can make, now if you look on the side there, I'm making the width bigger or smaller. And the trick I did is I set this to be as big, just to the point where the 200 starts to wash out and can't get any bigger. Right, so there we go. That's about the right place. That's just sort of visually so that it works nicely. So I go back through time. You can see my scale. Now my maximum wind speed scale is staying the same. And there are quite a lot of points where we're seeing like winds of 100 knots. So the last little trick here that I did is I colored. I colored this by pressure. So let's check our pressures to see what the range of pressures are like. Check pressure. And just drag those over. Pressure. And make that dimension. And make it discrete again. And I'll just drop the count in. Most of the pressures are null, and that's because we have a lot of older data. And then they top out at 1024, and the smallest is 872. So if I go from 850 to 1050, I catch the whole range. And I can, again, it's the same problem of by default it'll change the range on every one. And so let's just start with the default. So I'm going to take the minimum pressure and I'm going to color by it. And if you watch, it'll change. Yeah, you can see the minimum changing on every one. Weird animation there. So that animation is being weird. We can actually change that animation. So we can go into format, animations, and I'm going to turn it off for all sheets by default. And then what I can do for specific sheets, I can turn the animation off. So without the animation, it doesn't go smooth anymore. See how it just jumps? With the animation on for this one sheet, what it's trying to do is it's trying to go smoothly between them. So for now, I'm just going to turn it off because that's kind of jarring. Anybody remember which is worse, low pressure or high pressure for a storm? Low pressure, yeah. Right, so let's adapt the colors and standardize them, right? So we want to have these standardized across all years. I'm going to go with the VIZ color scheme because I thought that worked pretty well. So dark means nice and safe. Bright yellow means we're in big trouble. And I'm going to modify the range so that it's standardized. So I could go 850, but yeah, you can go between 850 and 1050. So we've got 200 millibars of range in there, which is more than enough. the center's fine, I'm gonna use that.
Can you repeat the
Huh. 1986, really missing that many pressure. Okay. What I'm gonna do is I'm gonna break this up by basin and by year. There's something, I think I might have made basin name and, well, I won't do by year, but I guess it just took a long time before they started recording pressures. So, how long ago? I think back into 1986. Yeah, missing pressure. Oh, okay. So this is the other thing. So, by default, this is saying missing pressure is being treated as a 0. But what we really should do is we should probably set the missing pressure as if it's not a serious danger, right? So we should probably set the missing pressure to be close to the maximum of the range. So we could. The idea is we would want to override this missing minimum pressure. So we can edit this in place. I'm going to slide this across. I'm going to edit this in place, right? So I've got this aggregate. Oh, and also this is probably safer as an attribute. So I can change this to attribute. So let's start with that. Let's change both of these to attributes. Doesn't break anything, that's good. Change this to an attribute. And we'll just check this one, that's an exact date, that's fine. And we'll just do a little bit of scrolling. All right. So I want missing pressures to be displayed as dark as possible. So I'm going to go in and I'm going to edit in shelf, and I'm going to add a special function called if null. And it does almost exactly what it sounds like. It's saying, if this thing is null, replace it with something else. And what do I want to replace it with? How about 1,000? That's pretty good. So there we go. Yeah. So I can edit this in shelf. And actually, let's find a year with lots of missing data. So I'm gonna, let's get rid of it. I'm gonna edit this in shelf, and I'm gonna get rid of what we have right now. I'm gonna delete this, and I'm just gonna leave it as an attribute. And you can see all these tracks end up looking really bad, right? They all look bright yellow. And the reason is because if we look at this, we're missing the minimum pressure. So what I want to do is I want to say that if we're missing the minimum pressure, actually set this to like a darker value, right? Instead of treating it like a 0, which is what it's doing, I treat it like it's actually a higher pressure zone, that is less dangerous. So what I want to do is, when this is missing, when it's null, replace it with 1,000. But I just want to do it for this chart. I don't want to do it for all the data. So if you have kind of like an off-the-cuff, one-off calculation you need to do just for one chart, you can do something called editing in the shelf. So we can edit in the shelf, and you can see now you can edit. I can type in to the actual bar here. And so what I'm going to type in is inside of the attribute. I'm going to say if null, and it requires two parts. The first thing is what we're checking to see if it's null. So I'm checking the minimum pressure to see if it's null, and then if it is null, return 1,000. And then what if null does, if it's not null, is just return the value itself. So I'm going to say if it's null, return 1,000. If not, return itself. Hit enter, and there we go.
So can you show me? Just give me a second, the end part.
Edit shelf, and
Okay.
and what I did is I
Yeah, this is
attribute
fine.
if null, and then and so watch, if I set this to 800, it's gonna go back to yellow. So we'll set it to 800, it goes to yellow. If I set it to 900, 900 goes to kind of green, and that gives me an idea for parameter. Why don't I create a parameter? Why don't I create parameter? Create parameter, and I'm gonna call it default
So
pressure.
why did we edit this function to make like if null value, and why did we do this?
Yeah, let me just set this up and I'll explain that in a second. So we're gonna do integer display format 0, allowed range, I'll do 800 over the whole range, 850 to 1050, and we'll do step sizes of 50. Okay. So the reason why we did this is because if edit and shell, if we didn't do this, it would be the equivalent of the display being like this, the display being 850. So the reason why we did this is because it makes it look like the storms are really, really intense and then get quiet and then get really intense again, right? And the reason why the yellow is showing up is because Tableau is treating missing values like they're 0, right? And so we want to replace this missing value with a number that makes more graphical sense for how storms work. And we know that storms will generally start off less intense, that is higher pressure. They'll get to a lower pressure as they get more intense, and then as they taper off, the pressure should get back higher again. So what we want to do is treat missing values like it's high pressure. Now that I've created a parameter, I can actually use that parameter instead. So I can say default pressure. Hit enter, and now we can actually play with this coloring. So I can show the parameter control, and it's currently at 850. Step it up to 900. Looks greenish. To 950. Still looks kind of a mid-green. 10 is blue, and then 1050 is like the true dark blue. And I might actually edit this and make it range over 20 steps of 25 would probably be a little more. So again, if we go all the way back, this is kind of how Tableau is default treating things if we hadn't put in all those edits, right? So we edited it in place, and then what we've done is we've said, hey, you know what? I don't want to look like the storms are being really intense and then less intense. They should start off as being pretty unintense and then becoming more intense. And then what we can do is we can kind of scroll through the years, just make sure this makes sense. And you can see some years they did get some sporadic pressure readings, and so this is not really working out for like really early years, 225 years ago.
So what is the formula for default pressure?
So default pressure is a parameter. So we go edit parameter, and what I did is I said the parameter is going to be an integer, and I should probably put in the units. Millibars. So, edit. So I said it's a default pressure is the title. It's going to be an integer. Just a regular display format is fine. And then I made it a range, right? So you can see all given values. You can specify a single list of values, or you can do a range.
This is a calculator field, or this
is a parameter.
Okay.
That's a calculated field. You want to do a parameter.
Okay.
And then I just set the min and the max to match the min and the max that I'm doing the colors over. Set OK. And So I think that's, let's see. I believe that caught almost everything I did. Now, the only other thing that I did on this first sheet, there's two others that we'll cover next week, or sorry, next class. One is actually getting things to animate nicely, and there's a neat little trick with embedding visuals. So I can highlight over this, and I've got like the storm intensity of pressure and wind. Let's see. So I've got. Oh, the only other thing I did there is I just edited the. I'm gonna go back to the one we're working on. So you can see that there's a lot of data in that tooltip, and really, what I want to do is just sort of highlight which storm it is for the year. I don't even need to really know what time of day it is or anything like that. So I just went into the tooltip and I said, get rid of everything that isn't a storm name. Just simplify it down to something really nice and transparent. Now the other thing I did with the tooltip is I just wanted the tooltip to be super nice. So I'm keeping it as responsive so that it just it shows up as soon as I highlight it. But I don't want any of the command buttons like select the data, show the data or filter, and I don't want to use it for selection. So I'm just gonna unclick both of these, and I can actually preview it. So that's what it looks like. So let's include the command buttons, and oops. So we'll start off like this. So if you look at this, when I click on it, there's a bunch of buttons that show up, including grouping members together, looking at the actual data. So I'm going to get rid of all those. I'm going to get rid of all of those. So first one I'm going to do is get rid of allow selection by category, and let's see what happens when I click on a data point. It didn't change much, and then what I can do is I can get rid of include command buttons. Say OK, and now when I click on it, it doesn't do anything, right? That's it. And finally, there are different ways of making, so you can actually not show tooltips at all. And now when I go over here, you can see it picks stuff up, but it doesn't actually show anything. I can show tooltips, but I can set on how they work. So show tooltips on hover means that if I'm just going over it, it doesn't take long, but then I have to hover for a little bit to show the tooltips. The show tooltips responsive is an instantaneous one. You can see as I go over it, just shows all of it. So I'll share this. I'll post this workbook up, and I think we've made it through class. Any questions about sort of the basics of geographic geographic plotting? No? Good? Okay. We'll do some geographic animation and maybe even get into...
Where we did use this parameter, sir? Default parameter.
Oh, watch what happens with the default parameter. I've used it here in the attribute. So we edit in shelf, and I'm gonna make this big.
Okay, got it.
Yeah.
Got it, sir.
Yeah. And then because I've got it in there, I can... Why is... Oh, you can see there's a couple null values that it's showing up. Oh, I set the, I must have overridden the range of values. So, edit this. Oh, step size, that should be 25. There we go, that's better. So there's no missing value, there's just a couple of tracks of missing values there. All right. All right, so next class on Thursday, we will set up some animations so that we can actually watch the storms move over time, over the course of the season. And I can actually even just cheat a little bit and show you a bit of a preview. I'll set this to fast. So we're gonna basically play around and set up just a, kind of like a clever little,
This is done by you?
Yeah.
You didn't tell us, right?
No, we're doing this on Thursday.
Now.
Yeah, yeah.
Very nice.
So,
Very nice.
yeah. And the other neat little thing that I've got in here is I've got a hover over graph of its intensity over time. So we can follow the intensity. So I'll cover how to do these little tricks there.
What the fuck? Is it?
मेरी फ्राइडे